So here is what our activity is, okay? One of the proofs will be based on the puzzle that you will complete today, all right? So each, I'm going to hand out, give you a bag of puzzle pieces. So in each bag, okay, you know what? Let me give this out. So I'll give a bag. So there are 4 different puzzles here. So I use different colors, okay? So there are 4 different puzzles. I'll give you, you might get a puzzle different from the group right next to you. So, okay. The first thing I need you to do in your group is take out all the pieces. I know you are all responsible, so that's why I didn't really assign specific rules to for each member in the group, but we'll see. I notice that some of you are not engaged, then I'll do something about it. But for now, I need you guys to take out all the pieces. So inside each bag are 2 puzzle frames. Okay. You should have 2 puzzle frames. Okay? So you have this. I actually use a regular copy paper so you can differentiate the frames from, these are the actual puzzle pieces. Okay? These are the frames. Did you find the frames? Okay. How many? And then you have 3 square pieces. Check your set. And you have 8 triangles. Please raise your hand if you do not have a complete set. Are we good? So here is the first thing that I need you to do. I need you to find out whether or not these puzzle pieces, I mean the triangles, are related to the square pieces. Remember, this is not part of, this one are your frames, okay? These are your puzzle pieces. So the first thing I need you to find out in your group is whether or not the size of the squares are related to the size of the triangles. Start.
Do you want to try it? Okay. Yes. Let's try this, the middle one first. That could be. How do the side lengths of the squares compare to the side lengths of the triangle? Well, complete. And what Alexandra did earlier with this one. Yeah. Oh, yep. Wait.
Okay, let's do this one. Okay, so one, I can see that some of you are already have already started putting the pieces together. Okay, so I just need you to stop for now. Just want to make sure that you understand what we're doing here. Okay. Okay. So first, I need a leader from each group. I need a recorder. I need a presenter. Okay? And I need a task master. Basically, the task master will see to it that the group is on the group is on task. Okay? The leader is responsible for making sure that well, the leader and the task master basically will have similar roles. Okay? Make sure you appoint a presenter. Make sure you appoint a recorder. Okay? The recorder will be the one to write down, to record whatever observations you've made based on the questions in the task. Okay?
Is that on task?
Say again? Okay.
Wait, are you gonna do this one?
Hold on. That's a good question, Kiara.
Because if all the signs are same on here, then you know if these two are the same.
So, who is the recorder here? So you should be holding this one then, right? The task. Who is the leader here? The taskmaster. Okay. So make sure that you are on top of the activity. We're good here?
Yes.
Everyone has a role? Everyone has a role here? What is your role, sir? Good. Everyone has a role here? Okay. So, is there a relationship between the squares, the lengths of the squares, and the lengths of a triangle? What have you noticed about the triangles, by the way? What have you noticed about the triangles?
That they create a square when you put two together.
Just the triangles. Okay, so the two triangles will create a square. What else? Desiree? So you're saying all the triangles are right triangles. Did you guys find the same thing?
Yes.
Okay. How about the size of the triangles? How about the size of the triangles? Kiara, how about the size of the triangles?
What I noticed about the size triangle, that each of the squares equal up to one of the sides.
Okay, but I'm asking about that's a good observation. But I'm asking about the size of the triangles. Just look at the triangles. Compare their sizes. Are they congruent? Do they have the same sizes?
Yes.
Raise your hand if you notice the same thing. Because remember, you have different puzzle pieces. Are all your triangles congruent? Okay, so I need you to work for 5 minutes for now. I need you to address A and B. Okay, start.
So lengths of the squares compared to the side lengths of the triangle.
I didn't hear a word you said.
Okay,
Study.
go ahead.
Study a triangle piece and the 3 square puzzle pieces. How do the side lengths of the squares compare to the side lengths of the triangle?
Can I draw something? How do the side lengths of the squares compare to this one fits? Let me grab another one. You see? Another one. Another one.
And is that true? Well, will that work for this? For this? For this?
Yeah, they're all equal.
Because they're all equal.
Right there.
Yes. Go ahead.
If we're supposed to make like the puzzle pieces all fit into one of the squares.
Okay. Who is the taskmaster here? Okay. So taskmaster, why don't you read that part of the direction that has to do with putting the pieces together?
Arrange the puzzle pieces to fit exactly into 2 puzzle frames. Get your arrangement below.
So did that answer the question?
Yes.
Okay.
Thank
So taskmaster, you're responsible for making sure that you know exactly what you're doing. Then refer back to the task, right? But have you already addressed the first one? No.
Yeah, she's writing it down.
Okay. You're the recorder? Okay, very good. You're on task right here.
So you're gonna just put them all in there. Put another square right here. Yeah, I know. I'm telling you what to do in this one.
Okay, so what are we doing right now?
We're gonna write down A. Draw the answer.
So so did you already discuss A?
Yeah.
Okay. So you're the recorder, Jonathan? Okay. So while Jonathan is so you know what okay. So who is the taskmaster here? Why don't you, before Jonathan starts writing for A, why don't you read B1 so the rest of your classmates can start working on. The rest of the members in your group can start working on part 1. B part 1.
Only one. Okay. One side because this one.
So again, taskmaster, leader, you have to make sure that everybody in the group
Sideline.
Yeah.
knows what he or she is doing.
The single triangle.
Okay. Do we know what? So okay, you're doing you're working on A. So you know what you should be doing next. Okay. So the task is also up there. Let's see. Why don't you read that to them and see if they agree, if that's the idea that they were thinking a while ago.
We told him to write that. Because
Okay.
that's what me and her came up with.
So okay, good. So then, taskmaster, take it away. So B1 now.
Alright, arrange the 11 puzzle pieces to fit exactly into the 2 puzzle
I
frames.
want you guys to help me understand this.
That's an awesome explanation right there. So this one will help you understand. This one, yeah.
I try to do it first so I could understand and get the group.
You see, and that's important because we look at things differently, right? And so I didn't do it this way. I didn't order the questions so that you'll follow it in the well, it will make sense for you to complete this first, but the thing is, this one will actually help. They're related. That's what you're trying to say.
They're just
Awesome.
all related.
Yeah. So Ariana, what is your role here again?
Taskmaster.
Okay, so you think the group so far is on task?
Okay.
Good. So then you go back there, right? And you talk about that?
The hypotenuse of a regular triangle is related to the big square and the what should we call it? One of the legs, the height.
Okay.
One of the legs. Bless you.
Okay. I just want to check in on you. How are we doing, 811?
Like
Okay,
one
good.
of each leg. One.
Mr. Pasco.
I would never thought of that.
I thought of this. Careful.
What do you think?
I was doing that. I was doing that, but she
All
took
right.
it away.
So, oh, you're drawing it?
Yeah.
Okay. So now, pay attention to the next question, okay? Well, make sure that, well, but since Vanessa is only sketching this, why don't you taskmaster, Vanessa, do you mind if, well, why don't you, Raimundo, read the next part so the rest of the group can start working on it,
You didn't think of that.
okay?
Conclusion, can you draw like the
I did that one.
That's what I said. That one in the center.
No. And he was like putting the square in the corner. Like
Who is the taskmaster here? So why don't you guys start working on 2? So did you already, were you able to, no, you were able to fit all the pieces, right, in the 2 frames? So then, go ahead, I'm sorry to interrupt.
At first to find the second one, but easily he got it.
Excellent. So what conclusion, what have you observed so far in terms of the relationship among the 3 squares? Okay, so I'm actually talking about the next question. So I'm getting ahead of your activity here, but taskmaster, the next question has to do with relationship among the square pieces, right? So you start talking about that.
Well, I'm drawing. Look, I'm not doing 4.
Awesome. So you have 1. Yes. Did you talk about the issue in your group?
Yes,
Okay.
we know this. It's just hard to explain.
It's just hard to explain.
Okay, so what are you trying to say? Go ahead.
Okay. You want me to say it?
Laura found out and shared to the group that
Okay, so hold on. Before you say anything, Laura, so can you talk? Can you share to the group your understanding of the question? So what were you asking, A?
How do the side lengths of the triangle equal to the side lengths of the squares?
Related, not equal. How are they related, right? How are the side lengths of a triangle related to the side lengths of the squares? So why don't you pick a triangle and pick the 3 squares and see if there is a relationship among the sides of this right triangle and the sides of the 3 squares. Okay? Okay, put it down. Put it on the. You wanna give it a try? What?
That's mostly what we found out.
Oh. So how are they related?
we don't know how to
Explain it in words.
So okay, so
because
talk about it.
we don't have because these 2 are named legs and this is the hypotenuse.
Hypotenuse. So don't the legs have different names beside legs, so you wouldn't confuse?
So you're having an issue with differentiating the two legs.
Yeah.
So why don't you just say like the one square fits, a side of a square fits one leg, a side of the other square fits the other leg, and then the third square fits the hypotenuse. How about if you say that? Leg one, leg two. You're right? I mean, there are many ways to differentiate the two legs. But yeah, that's a good problem to solve right there. So you find a way to differentiate them, number them, assign letters to them, variables. Did that help, just Molly?
Yes.
Excellent.
It could be vertical leg and horizontal leg.
Oh, you had one.
Okay.
Awesome.
That's better.
Okay.
Maybe you could try making like two of this.
Why it has to be so big? It doesn't make it big.
I'm dead. I'm gonna keep that in mind, Mariah. Thank you so much.
So what specific relationship are we looking for in number 2? Relationship of what? Among what?
Among the areas of the 3 square pieces.
So you're talking. So first of all, okay, can you put them together again?
Yeah.
Well, you have your sketch there anyway, so
Somewhat.
yeah, that's fine. But okay, that's fine. So you have
Sure, go right
now. Do the 2 frames have the same areas?
Yeah.
Did you try to put one on top of the other and they match? Because don't you think that would be a good starting point to make sure that to see if the frames have the same areas? Do they have the same areas?
Let's find out right now.
Yeah, great.
Well, mine are the yellow pieces.
So they have the. What do you think?
Yeah.
They have the same areas.
Mine's all like yellow.
That's a good start. So we've established that, right? Okay, separate the 2 frames.
Okay.
Okay, take it from there. So you know that the 2 frames have the same areas, and you're trying to determine the type of relationship that these 2 squares and that square has.
Has on the
Okay,
triangles?
No,
Wait, has on the what?
among the areas of the, just in general, the 3.
I know you have an emergency, so you know what to do.
squares on one frame.
Okay, hold on, but you're the taskmaster, right? You know what do you know what they should be working on right now? Okay. So what relationship have you discovered so far?
The same one that we discovered
Really?
first, yeah. Because here there are 4 squares and here there are 4 squares.
Hold on, how many squares are there?
I mean, triangles.
triangles.
Oh, no, okay.
So the amount of triangles is equal.
Why are they? Why? How do you know that the amount of triangles there are equal?
Because there are 4 here and 4 there.
And do they have the same sizes?
Yeah.
Okay, I just want to make that clear. So yeah, there are 4 triangles, but are all the triangles congruent?
Yes.
So you're saying since it's 4 triangles of the same area, I mean each triangle has all the triangles of the same area. So if I have 4 here, I have 4 here, each have the same areas. Go ahead.
Yeah. So
Are you following this so far, Alberto?
So if you were to remove the triangles from the picture, you'll have equal areas because since they had the same amount of equal triangles, that means that they would have to be equal.
You're convinced by that argument? I am so convinced. Awesome. Okay, you're doing a great job, guys. Okay, how are we doing here? Oh, we found a pattern. Excellent. Okay. So, while Lashira is drawing the sketch, right? Why don't you two talk about the next one, which is so now you have to figure out whether or not there is a relationship among those 3 squares. Okay?
What's the relationship? Let's go. You figure this.
But then this one is not.
Hold on. Say it again.
We have one good square, right? Can we use one of the pieces?
No. Remember the pieces, you're trying to fit all the pieces in the 2 frames.
All right.
Yeah. You're trying, so if you can't do it, then just, we'll see. But see if you can. I know the cutouts are not really precise, but make sure that the figures don't overlap.
Oh my god! It's not gonna fit. It's gonna be like that.
Okay, try it. I mean, there are 4. I'll give you another. So you guys, I'll give you another. I an extra set here. I have an extra set here, so you can do this fast. So why don't you two do the other one so you can maximize the time. We found the two puzzles here.
Give me that.
We're able to fit everything here. So what?
I mean, nice. Because Kimberly is getting confused between the frame.
No.
and
This is the
square.
frame. Okay, so hold on. Put it down. Put the square down. Okay, can you show me again? Okay, show it like that. So why don't you use the terminal? Why don't you describe the square in relation to the side of the right triangle that it's drawn on?
How about we just name it A, B, C?
Okay, remember I already clarified that?
Right.
For example, you can say this square, the smaller square attached to a leg. This is a larger square attached to the other leg, and this is the largest. Don't you think this is the largest square? Yeah. What do you think? Yeah, and the largest square attached to the hypotenuse.
Yeah, there you go. We're going.
Right? Because I think these squares. Do these squares have different sizes?
Yes.
Yeah, so you can talk about that. So the smallest square, the larger square, and then the largest square. But you have to be specific as to how those squares are related to the size of the right triangle. Okay? And remember, you gotta use the appropriate vocabulary: leg, hypotenuse. All right? Are we good?
We found out that the
Is related to the larger square.
is related to the
Awesome,
larger
you
square.
found it? Oh, Eureka! You know
And the legs.
Awesome. All right. Okay. Now, who is the taskmaster here? So, why don't you, before you draw the sketch, why don't you, Angelina, discuss with your group the next task so they can start thinking about it.
What conclusions can you draw about the relationship along the areas of the three square pieces?
No, you don't have to ask permission because
three square
this is.
Okay, so I got this.
Go ahead and do the next one.
So areas of Pasco door. Okay. Okay, not low. Oh yeah. Alright, the areas of 1, 2, and 3. Now this is
Where's the third?
Okay, are we good here? Okay, so
Wait, no.
do not dismantle your puzzle pieces because you need those puzzles to complete the rest of the task.
Fail.
Okay?
But I use the big squares for that. These in the puzzle pieces. Look. Wait, I got this. I could do this.
Okay, can you do me a favor here? So you're working on this? Oh, who is the recorder here again?
The vertical leg.
So who is the recorder here? So I need you, Alberto, to draw the sketch.
The right triangle.
Of the left triangle.
And so I need you to draw the sketch here, just the sketch, all right? And then the rest of you should work taskmaster. Have you completed the activity already? Put it like that.
Alberto, please. Ariel, ayúdame. And do it in pencil first.
So,
Okay.
they are still working on
while you're
okay.
gone.
Hold on. So, who is the recorder here? So did you talk about all these in your group? So the areas of the two smaller squares equal to the area of the big square. Can you guys clarify the vocabulary here by describing exactly which squares are you talking about in relation to the legs and the hypotenuse of the triangle? You know what I mean? So, for example, you're talking about smaller squares here. How are these squares drawn in relation to the size of the triangle? Are they drawn in relation to the legs or to the hypotenuse?
The legs.
Okay? So I need you to be more specific in your, more detailed in your description here. Okay? All right. 1, 2, 3.
Oh, they're coming.
Okay. the side lengths of a triangle? Presenter in each group?
I'm not the presenter later.
Um,
Yeah, the areas of the legs.
okay, Jonathan's group, who is your presenter? Okay, so Dennis, did you find anything, any relationship among the side lengths of the squares, the square pieces, and a triangle, the size of a triangle? Okay, so what relationship did you notice?
Side lengths of the squares compared to side lengths of the triangle. The lengths of each square are the same as the triangle.
The lengths of the size of the squares are the same as the size of a triangle? What do you mean by that? Can you come up here and draw a sketch of what you mean? What do you mean by that, Dennis? Can you show us a drawing that will support your reasoning there, your statement? Can someone in your group clarify, help Dennis clarify that idea? Jonathan? Okay, why don't you come up here, Jonathan, and draw, show us a figure that will help us understand what Dennis was talking about. Just take it easy, Jonathan. Take your time. Okay. Who else found the same relationship? Remember, you have different puzzle sets, right? So did you guys find the same relationships among the side lengths of the square, the three squares, and the size of a triangle? Any comments on that? Just Murli's group, it seems like you're discussing something. Do you want to share something to the class about that question? Thank you, Jonathan.
Well, in other words, we wrote exactly what he did, only that we didn't draw it, we wrote it.
Okay. So do you guys think that that drawing helps clarify Dennis's thinking?
Yes.
Okay. So again, you can represent an idea in many different ways. Okay. You have to realize that. So everybody found the same. We are on the same page. In other words, here. Good. So then, part B. Can someone share one of their sketches? Who is the recorder in your group, Mariah? So Alexandra, do you mind going to the board and just sketch it? Remember, we're just drawing a sketch. So it doesn't have to be perfect. Okay. So show us one possible arrangement. You guys, did all the pieces? How many puzzle pieces are there?
11.
11. Did all the 11 puzzle pieces fit in those two frames?
Yes.
And again, I want you to bear in mind that you had 4 different puzzle pieces. I mean puzzle sets. Okay? So that means that your triangles were actually different, of different sizes, and the squares as well. So I want you to bear that in mind. So we are on the same page, but bear in mind that we're dealing with 4 different puzzle sets. Okay, so I want you to notice the outline of Alexandra's puzzle, one frame. So if you came up with another arrangement, could you come up there and draw your arrangement? Johan, thank you for volunteering. So just do it on the other side, in that same space. So everyone is able to, I was able to fit all the pieces together. Put all the pieces together, I mean.
Yes.
Okay, so Alexandra's group, what do you think of Alexandra's sketch? Does that reflect your arrangement? So I'm just wondering why there are, so remember that we're dealing with size here. So this is just like you're just being, were you just trying to be artistic here, or okay, so the outline, you want to show the outline of the triangle. But did all the pieces fit more or less snugly together? Yeah. So there are no spaces in between. Okay? I just want to make that clear, okay? And we have another arrangement for Johan there. So who came up with this arrangement? Who came up with this arrangement? Okay, who came up with this arrangement, this other arrangement? Did any one of you come up with a different arrangement? Why don't you come up here and show us your arrangement? So which one here? Is it quite similar to Alexandra's or to Johan's? Okay, so can you put that piece here?
This one? Yeah. Isn't that one?
Kiara, I need you guys to, who is the recorder here? Okay, I need you to write your explanations for 2 and 3 on this paper. Sorry. All right, for 2 and 3. Okay. Who came up with that arrangement? All right, so is that somehow similar to this one right here? Oh no, right here. Or here. So you have the 2 smaller squares, right? And you have the 4 triangles there. And the 2 triangles actually form a rectangle. So same thing here, right? You have the rectangle here, you have a rectangle here, and then you have the 2 smaller squares. So does that make sense? Did any other group come up with a different arrangement? Okay, so let's label this as arrangement A. Okay? And since, do you agree guys that these 2 arrangements basically are similar? So can we label these 2 here as arrangement B? Is that okay? Is that fair? Yeah. Okay, so here is what I need. So we're about to discover something very important here. And I need you to take as much time as you can to think about this question. Based on these 2 arrangements, can you make a conjecture, a claim? Or can you draw a conclusion? Now we're drawing a conclusion. Because remember, you had different pieces. You had different puzzle sets, but you came up with apparently the same arrangements, right? I need you to think about the relationship between or among the areas of the square pieces. Okay? So, can you draw a conclusion about the relationship among the square pieces? Or you know where the square pieces here are? Okay. Do you have a clarification about that question? Do you have a question for me? Raise your hand if you know what I'm asking you to think about in the next few minutes. Raise your hand if you know what I'm asking about. Asking you to think about in the next few minutes. Okay. Then go ahead and think. Yes, sir. All right. Well, before you leave. So, can you guys? Do you know what you should be thinking about right now? What am I asking you to think about? Okay, can someone clarify to Dennis what I'm asking you to do right now? Okay.
Are these two the same or one?
This one is bigger than this one. So basically, this plus this equals.
Wait, take as much time as. So have you noticed any relationship so far? You noticed something?
This plus this.
No.
Okay. But remember.
I think that
Okay.
works.
But let me clarify the specific relationship that I'm asking you to think about. I'm asking you if you can draw a conclusion about the relationship among the areas of the squares. I want you to pay close attention to what I'm asking, because of course there are a lot of relationships you can draw from those puzzles, right? But I'm asking for a specific relationship. Can you draw a conclusion about the relationship among the areas of the square pieces? Okay?
So among the areas of the square pieces.
Okay, so do you know what I'm asking about? What specific relationship I was asking you to observe, to draw a conclusion from? So have you noticed anything? So what have you noticed? Did you have a discussion about that? Okay, go ahead.
That the areas of each square create a side of the right triangle.
Okay, but which is true. But we're talking about now we're concentrating on the three squares. Ariana, can you identify the three squares that we're talking about right now? Can you identify them? You know what? So I'm asking you to observe whether or not, based on these puzzle pieces that you put together, if you can somehow find a relationship between the areas of the three squares. We're looking at the three squares right now. Because you know the triangles are all the triangles congruent there?
Yeah.
Were all the triangles used in both frames?
Yes. Wait.
Were triangles used in both frames?
Yes.
So look at your puzzle pieces again and see if based on your arrangement you can draw a conclusion about the relationship between the areas of those squares, of the square pieces. Now, do the two frames have the same areas, by the way?
So remember.
Yes.
Anna, did you check? How do you know that? Did you check?
When we first got it, we put the two frames together.
Awesome.
And
So you
they're
put
the
it.
same size.
Good.
Meaning they have the same.
So why don't you start with that idea that these two have the same areas, right? So can you make and then apart from that, do you know how the sizes of the triangles are related? The size of the triangles.
Yes.
So what about the triangles? Do they have? What can you say about the areas of the triangles? Do they have the same areas?
Yes. All triangles.
That's another given there. There's another given fact there. So one fact is that these two frames have the same areas, right? Another fact. Do you agree that these frames have the same areas, Ariana? Kimberly? What's the other fact?
That all the triangles are used in each frame.
All the triangles have the same areas. Yes? So so look at your arrangement. So can you make a conclusion about the areas, about the relationship among the areas of the squares? Okay, continue that discussion in your group. Okay, so we found something interesting. So what have we found here?
Well, I don't see it. You see how you use four triangles to make sure?
Okay.
So that means these two put together equals to
And be sure to support your reasoning. Okay? So what have you noticed here?
The chart.
But how is the chart related to this?
Because the theorem is related to what we're doing.
In what way?
In the way that the
Okay, so you're
the equation of A plus B is always greater than C. I don't know how to say it.
okay, but you're talking about the lengths of the size.
Yeah.
But what are we concentrating on here? The areas of. So I need you to focus on on the specific quantities we're talking about. We're talking about the areas of the squares. We know, well, you already know that all the size of the squares will fit the size of the triangle. You already know that, right? So now we're talking about, so is there a relationship among those areas based on the puzzle, based on how you put those puzzle pieces together? Do these two frames have the same area?
Yeah.
How about the triangles? What can you say about the size of the triangles? Do they have the same sizes, all the triangles? Are the triangles used in both frames? So based on those facts, can you draw a conclusion between in regards to the relationship among the areas of the three squares? Knowing that these frames have the same areas, the triangles you used in both frames have the same areas. So can you now draw a conclusion? And then these squares have different areas, right? Do you agree with me?
Yeah.
So can you draw a conclusion? Can you describe a relationship among the areas of those squares? Okay, so what have you found here?
Write that in your hand.
Okay, is that specific enough?
What? No.
You'll see the
What do you
one.
mean by these two squares are equal to the big one? What do you mean by that?
Alright, so this, right?
What specific characteristic
He's
or
saying to
property
relate
of the squares that
how
you talk?
these three
You know what I mean?
squares
Like be specific.
the
I'm
area
talking
of
about
the
the shape of the squares, like the shape. Or these two squares are equal to the shape of the. So what specific property of this square are we talking about? Alright, don't you think that's a very important quantity that you have to mention in your description?
All of these areas are smaller.
So why don't you
than this whole
restate what you
area,
just observed
making it
and put it in writing?
Well, for one, they're
congruent
similar.
because
Okay.
if you put the area
One.
in here, you still got space, so you can put the area
Excuse
of the
me?
triangles in here and make the frame.
2. Okay, so you guys, I need you to. Okay. I need you to stop this right now. Okay. This is enough. I mean, I just need the sketches, so this should be enough. All right. And I need you to
Okay, let me try to
write
say that in
your
good
observation for
The area
number 2 here.
of
So
the
make
square
a
puzzle
conclusion. What conclusion
are
have you
smaller
drawn?
than
You
the
already
frame
have
puzzle
it.
pieces.
Okay, so I need you to share it in a
So
moment. All right.
if you put
Okay. 1, 2, 3. Any conclusions that you have drawn based on the areas of the squares? So I think you guys came up with this sketch, right? Does this fairly represent the puzzles that you put together? The two, okay? So you have it here. So anybody who any group? I think most of you. I know you need more time. Okay. So right now, in the interest of time, I think you're on your way of finding the relationship here. But let's see if what your classmates will share will make sense to you. Okay. So I need you to stop working right now. I need you to think about the statements that your classmates will share in a moment. I need you to process it, and please do not hesitate to clarify. Ask your classmate to explain his or her idea about the relationship among the areas of these squares. So, there are 6 groups here, so where are the other presenters? Michael's group, were you able to put that conclusion together? So why don't you share it to the class, please?
We observed that the side length of one of the squares was equal to one of the side lengths of the triangle.
Okay. So if I have a square, this one it shares a leg or the hypotenuse?
Leg.
Okay. Continue. There are 3 square pieces there.
Yeah, and the hypotenuse would be the biggest square, and the remaining side would be the smallest square.
Okay, this looks like an isosceles right triangle. So so you have this one right here. So this is a right triangle. This is your hypotenuse here. That's the square that is drawn that matches that matches the hypotenuse, and then you have the other square here. So you're saying all the sides of the right triangle match with a side of a square. Okay. So how about the relationship among the areas of the 3 square pieces? Have you found any relationship among the areas of the 3 square pieces, Johan?
I noticed that the largest square from side C, you can never put it with squares from side A or side B. It's impossible to complete the entire square by using square from side C and side A or side B.
So you're basically supporting what Michael just said, that the largest square, we can only match the hypotenuse. That's what you're trying to say. Okay. How about the areas of the squares? The areas of the 3 square pieces, have you found any relationship among the areas of these square pieces? Desiree?
When the area of the squares that are on the side of the legs are added, they'll be equal to the square that's on the side of the hypotenuse.
Okay, repeat it one more time, please.
When the squares on the legs, when the area of the square on the legs.
So areas of the squares. You're talking about the squares, 2 squares on the legs, right? On the 2 legs. When the areas of the squares on the legs
are added, the sum is equal to the area of the square on the hypotenuse.
Is equal to the area of the square. Did I transcribe your statement correctly, Desiree?
Yes.
Comments? I can see that you guys are thinking, and that's awesome. Please, if you have any comments, whether you disagree or agree, or you want to support Desiree's statement, okay? But it's really great to see you thinking right now. Does that make sense? Do you agree, disagree? Someone look at the puzzle, the 2 frames, how you put all those pieces together, and see if you can justify that. How do we know for sure that the areas of these 2 squares, if I add them, how do I know that these 2 pieces the areas of these two squares will actually match this square. Now, of course, I'm going to ask Desiree to explain, to support her conclusion here. But I really love it when you guys just look at the statement and thought about it. Do you want to hear Desiree's reasoning behind this? And we'll see if, well, first of all, let me just have a quick survey. Who thought that this statement, who came up with the same conclusion? Who came up with the same conclusion? Raise your hand higher. Awesome. Now, you guys, I told you at the beginning of this lesson that it is more than okay if it'll take a longer time for us to make sense of this, because you are trying to understand a very famous theorem that most students actually do not understand. And you have an opportunity today to develop an understanding of that, and we will keep on moving in that same direction, right? So Desiree, please convince us that your conclusion is valid.
Well, if you look at your puzzle pieces, all your...
Okay, so hold on, I'm sorry. Why don't you do that? Look at your puzzle pieces, how you put them together.
When you look at your puzzle pieces, all your triangles are congruent. And
let's take it one at a time. I'm sorry to interrupt you, Desiree, but I just want to make sure that the class is on the same page. Can you repeat your last statement?
They're all congruent.
What are all congruent?
Your triangles.
Do you agree, 811, that all the triangles in your puzzles, in those puzzle pieces, are congruent?
Yes.
Yes.
When you fit the shapes into the frame, there are 4 triangles in each frame.
Have you noticed that, 811? Yes. There are 4 pieces here, and you have 4 pieces here.
Since they're all congruent, they take up the same amount of space. So when you take the triangles out of the picture,
take that out. Take this out.
You're left with two smaller squares in the first frame and one larger scale and one larger square in the second frame. And if you were to measure the area of the full square of the frame before you were to do that, and you were to subtract the area that the triangles made, you would get equal amounts for the square.
Did we start with equal frames first of all, by the way?
Yeah.
Class, did we start with equal areas? These two, that's why I kept on asking you guys, do the 2 frames have the same areas? And you guys said yes, and I asked you why, how you knew. You actually started by putting those 2 puzzle frames together, and you notice that they overlap exactly, right? So that's what we started with. You had started with the same area, you cut this out, you cut equal areas. You cut pieces of equal areas. So whatever remains will have the same areas. Does that make sense? So does this therefore make sense? And you just proved the Pythagorean theorem geometrically. This is you just learned one of the proofs of the Pythagorean theorem. Now, some of you might not appreciate what you just achieved today, but that is huge. And I'm really, right now, I'm the proudest teacher in the world, and I'm just not saying this just to please people, honestly. So, the areas of the squares on the legs, the sum of the areas, so this is another way to say this, the sum of the areas of the 2 squares on the legs of a right triangle is equal to the area of the square on the hypotenuse of a right triangle. If we translate this into symbols, If we translate this into symbols, remember, so let's go back to Arduino. You remember this representation here?
Yeah.
So if we let the length of the legs represent the lengths of the legs by A and B and the hypotenuse by C, right? Then if we say that the areas, the sum, what is the area of this square, by the way? If the side is A, what is the area of this square? Hold on. How do you find the area of a square? Base times side. And what do you know about the area, the size of a square, the length of the size of a square? So if this is A, how do you find this must also be A, right? And what is the area therefore? So A times A, which is A squared. So this is the area of that square. And this square here?
B squared.
So area of that square is B times B. So let me just label, this is A squared here, this is B squared here, and this one here is
C squared.
area. Now I am misspelling the word. Okay, area is equal to C times C, which is, so can we state this using those symbols? Awesome. Eric. A squared plus B squared, A squared plus B squared equals C squared. And you just proved that Pythagorean theorem geometrically. Now take note, there are 300 plus proofs of the Pythagorean theorem, right? You were able to do one, and that is more than good enough. That's awesome.